Okay, so let's continue. It's being recorded now. So this is how the Anaconda looks like once you've downloaded it and installed it to your PC. And then I was trying to explain something in the classroom there that it has so many tools embedded in it. So this is the one we are making use of, which is called Jupyter Notebook. Once you click on it, once you install this Anaconda, all these packages come with it. So this is the Jupyter Notebook. You launch it. Once you launch it, it opens up like this in form of a back end kind of codes, and then it will now be running on any of your browsers. It will be running on your browser. So this is a browser which is how do they call it now? Chrome. So that's what is running on right now. So that's the tool we are using for it. So once it opens, this is how it will look like, and you'll be able to uh,
Please, your mouse, we find it difficult to see your cursor. I don't know if you can.
can
Um,
you see my cursor now? This is it. Are you seeing it?
okay, yes, yes, it's clear now.
Okay. Okay. So I was saying that once you load your Jupyter notebook and it opens like this in a small window, it will take you to your browser. And then when it takes you to your browser, it will take you to the home page of your device, like your local machine. That's where you now look out for where you want to write your code into. So I have Lenovo, we have data analytic course. So this is week 1. When I want to start writing my notes, I click on new, and this is Python. It will now open a new Jupyter notebook for me. So it has to take few minutes before it opens. So we have a Jupyter notebook that has not been used. This is a fresh notebook here. So that's that for the tool we are using. So let's be fast about what we are doing. In week 1, we are getting to introduce the basics in Python programming, and as well the key things that are needed to be known in Python programming for data science. So the objectives of this training is just Python basics for today. Then the first thing I'll be hitting very well is the introduction to Python. We know that by way of trying to explain what Python is actually a general purpose programming language. It's one of the programming language that is multi-purpose. You can use it for building websites. You can use it for building software. You can even use it to conduct data analysis, what you do in your Excel and all that. You can still use Python to do that. And then you can use it for analytics. So what analytics majorly does is it has to do with future predictions of things using artificial intelligence, and then using machine learning algorithms as well. And also, it can be used to create varieties of programs to solve problems. So if you're a mathematician, you can make use of NumPy, which is numerical Python that helps you to perform some numerical analysis. So by so doing, you can be able to solve problems very, very easily. So Python has become one of the most used programming language because its versatility and the user friendliness. One thing about Python is that the syntax in Python are very, 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 very simple. So I assure you, in less than 2 weeks, you'll be able to get yourself acquainted with some of the syntax in Python. So they are user friendly, and then as well, just for the record, Python was created by Guido van Rossum, and it was released in 1991. So it has been for a while now. And then the next thing we are going to hit is the data types. So under data types, we have 4 major types of data, or rather data types used in Python. When I mean data types, is the category in which your data falls in. So we have 4 of them. The first one is integers. When we talk about integers, they are just numbers. So these numbers are whole numbers. They don't have decimal, they don't have fractions, they are just whole numbers. So whenever you see a whole number used in any form of data, you realize you should know that that particular number is a whole number or is an integer. And then we have another type of data type, which is floats. So these floats, what they do is that they are actually numbers, but they are floating numbers. When I mean floating numbers, I'm talking about numbers that have decimal points. So when you see numbers in a data set that has decimal points, that particular column should signify to you that, oh, this is a float, or these numbers or this category of numbers are floats. And then the next thing is strings. So strings are basically letters or alphabet. You know, when you use letters or alphabets in Python, those guys are usually referred to as strings. But another thing you should note about string is that they are enclosed. They are always enclosed in quotation marks. We'll look at them when we are doing live coding very soon. They are usually enclosed in quotation marks. So if I should enclose a number in quotation mark, that number automatically becomes a string. Did you get that? If I enclose anything in a quotation mark, that particular thing that is enclosed becomes a string. So that's one of the things we should take note of. And then we have boolean. These boolean are just the true or false kind of variables or values rather. And then we'll look at data structures. So under data structures, we have data structures are usually used to store multiple types of the items. So when you want to store maybe different types of items, like you have an integer, you have a float, you have a string, you have a boolean, and you want to store all those guys into one particular place. So you make use of your data structure. So sometimes I used to refer to data structures as containers, because they allow you to incorporate other data types into them. So if the first one we have there is list. So we have list, we have tuples, we have sets, and then we have dictionaries. So we'll explain better when we go down. And then arithmetic operation. When we talk about arithmetic operation, Python can be used to perform various arithmetic operations. We have the addition and subtraction, the normal thing you do in your basic mathematics. And then we have multiplication and division. Those guys can be done with Python as well. And then we have exponential and binary. We can also do exponential with binary in Python. And then we have whole numbers. When we divide a number and it returns a whole number after dividing that number, that's when we refer to whole number division. And then there's also a remainder the kind of division that when you divide, we know two numbers are not divisible, but we still want to kind of force that division on those two numbers. So there will always be a remainder. That's when we say that we have a remainder kind of operation that is being done. So it returns a remainder after dividing A and B. So that is basically what that particular arithmetic operation does. And then we will look at Python conditional, where we have iterators, and then we have control flow. So the conditions first are the if statement. So under if statement is used to test if a condition, or to test a condition and execute a block of code. What this means is that it's like you sending a child to go get you, let's say, a biscuit, and then you now tell the child, if there is no biscuit, please buy gala, that kind of thing. So it's a condition you're giving that child, that when the child gets to the shop and the child does not see that biscuit, the next option, or the next block of statement you told the child should be executed. But if the child gets to the shop and that first condition is met, which is the biscuit, the child should purchase the biscuit. That's just what if statement does. So if the condition is true, then the code will run, the block of code will be executed. And then we also have Python loops. So under Python loops, where we are looking at executing a block of code repeatedly. So this one is like, while this statement is true, we want you to continue doing this. So while Sunday is while the first day in the week is Sunday, we want people to continue going to church if you're a Christian. So that's exactly what Python loops does. If that statement is true, let a particular event continue happening. So as long as a condition is met, that particular event or that particular block of code will continue executing repeatedly. And then we have functions. So under functions, what we look at under functions is just like we are trying to customize our own code and ensure we can reuse that code to perform tasks later on. So this is it now. I have a particular formula, and then I can use that formula to solve any problem with where, provided the problem is related to, sorry, the problem, yes, is related to that formula. So what I'm saying in essence is that when we write a function, we are saying that we want to use this function to solve a problem whenever we have a similar problem like that. So we make use of that function. So function is a reusable block of code that performs a specific task, and then it helps us to organize our code. So when you write code in functions, they look very, very neat. And one of the zine of Python is that your code has to be very neat, and simple is better than complex. So let's try to see what we can do very, very quickly. So we have data types, and the first data type there is, we said, is integers, and then we're saying that integers are what? Numbers. And then we have floats, floating numbers, strings, and alphabets. So we're not repeating all that now. Okay, so my first line of code here is x is equal to x is equal to 2. So when I say x is equal to 2, this is what it means. This x is a variable and 2 is a value that is assigned to. Someone is trying to distract me. Can you hear me?
I can hear you, sir.
Okay. So
Please.
when we say x is equal to 2, it means that x is a variable and then 2 is a value which is assigned to this x2. Are we following? So if you see this x is equal to 2 without somebody telling you, you already know that the kind of data type which x variable is carrying is known as what? Integers, right? Because it's a whole number that is the value. So if you want to check that, you just do x is equal to 2, and then you trying to check the data type will be, you just use type, the keyword type x will now give you the value of what x is. So we have int. If we go back to what I showed you previously, I was having, let's do that. I was having integers, I have int. I was having floats, I have floats. I was having string, I have str. So these guys are their key words. They are their keywords for you to identify that this particular data is an integer. So here we've specifically checked, and then we've seen that x being equal to 2 is actually an integer. You understand that? And then we want to also look at y. Let's see what y has to do. We say that y is equal to 12.0. So we also know that y is a variable, and we give y a value of 12.2. So when we give y a value of 12.2, let's check the type, that the data type of y. So we just write type y will give us what is a float. So because of this decimal number, we now know that y is what a float. But when we remove this 12.0 and we rerun this, it becomes an integer. So we see the difference there now. So we see the difference there. So this remains a float until the decimal point is being removed. And then we have another one. My name is we have a variable, my name. So there's a variable name here, my name, and I assigned Ebenezer to the name. And then when I remember something I said about strings, I said that strings are always enclosed in a quotation mark. So I have a quotation mark like that. I have a quotation mark here. So when I'm checking the type of data, this guy is, I will see that this is a string, which is str. STR stands for a string. So that automatically lets you know that anything that's enclosed in this uh, quotation mark becomes a string. So let's go back to this guy and try to enclose this in a quotation mark and see if it will give us a string. So let's rerun this code. It gives us what? A string. So once you put a quotation mark, be it a double quotation or a single quotation mark, it becomes what? A string. So let's undo that and still move ahead. So the same thing goes for my
Continue
sorry.
short, sir. Continue short. I think some couple of guys just complaining that they can't hear. I
Oh
think
my
Mr.
God.
So I don't know. Can you all hear him?
Is there anybody
Yeah,
that's not hearing
I
me?
can clearly. I've been hearing him.
Who is not hearing me? Please identify. Identify. Let me know.
I think Mr. Hansel Anusike, you said you can't hear him, no audio. Can you hear him now?
Hansel is not even on the call now. I'm not seeing Hansel now.
Please, sir, go on.
Okay.
Oh,
Sorry
sorry
for.
to ask, sir. Where are you getting your
Okay.
material from so I can follow along?
Okay. Do you want to get the material now? I wanted after the class I can push the material to the classroom. Or do you want to do it alongside with me? Let's say something now so that I will know what I'm doing. I can easily drop it on the classroom now and then we continue. How about that? Okay, let's go ahead. No response. I was saying that for my surname, the same thing because it's been enclosed in a quotation mark. It's actually a string, and then I have another data type like this, which is z being equal to true. So remember what I said about booleans. Booleans are true or false statements. Sorry, not true or false statement, rather true or false value. So we have to be very careful with the tenses we are using. So true or false value. So if I'm checking the type of z, this guy should be giving me boolean. So this is bool, just like what I indicated in the bracket there. So when I run this block of code, you'll see that the first, this is an integer which is 2, and then the class is what? Integer. So there's something I think I should show us for you to be able to print all those things I did. The word you make use of is a keyword known as print. So if I say print and then I open a bracket and then I type whatsoever I want to print, let's say my name is Eben. And then when I run this code, what will come out is what? My name is Eben. So this is just how simple Python looks like. So you know that when you say print, it means that you should do what? You should output what is inside this bracket. And when you're telling the Python to output what is inside the bracket, it will definitely bring out what is inside the bracket. I don't know if you understand what I mean by that. And then that's why I said here, print this is integer. And then there's another thing I need to explain, the function of this f. This f is called a formatting tool. A formatting tool. So what f does is that when I place f at this position and then I want to say then name is, and then I put a, how do they call this? I think a colon, and then I come here and say, or rather, let me remove the colon. Let's go this way. I put a curly bracket, and then I go look for where my name is. This is my name. I copy the variable name and come place it here. So when I place the variable name which is bearing my name actually in the actual sense, this will output my name, which is my name is what? Ebenezer. So that is what this f function does here. So it allows you to call another variable name. So even if I come here and say y, I can copy this y, and then if I remove my name and I input y, this will give me my name is 12.0. I hope we understand what I'm saying right now. So this f allows you to format this text in the sense that whatsoever I input into this curly bracket here becomes what will be printed at the end of the day. So let's go back. I think we should have my name there. Yeah, let's have my name there, and then that is correct. So we are done with data types. So if there's any question, just keep them reserved. We'll be attending to them very, very shortly. So we now look at data structures. Like I explained previously, I was saying that data structures are used to store multiple items. So when I mean by multiple items, I'm trying to say that we can store integers, we can store floats, we can store booleans inside a particular data, structures. And then the list of the types of them we have is, the first one is list. So list is actually created by using a square bracket. So when you use a square bracket, um that square bracket will always produce a list. So items are ordered, changeable, and allowed duplicate values. So these are just I want to say they are the characteristics of a list. So in list, you can order the items, you can change the items, and then you can it allows for duplicate items inside that particular list. Then we have another type which is known as tuples. So when we talk about tuples, they are created with the use of curve bracket or round brackets. So when you see this guy used in any way, we refer that to a tuple. So one thing about tuple is that they are immutable. When we mean immutable, you cannot change anything that is inside a tuple. So tuple only allows for items that are not changeable. So, but they can be ordered. Those items are ordered, and then those items can also be what, duplicated. So but then they cannot be unchanged. So that settles that for tuples. And then we have sets. So just like the mathematical sets that is being taught in school, sets are being created with the use of curly brackets. So when we make use of curly brackets to create a particular data structure, we are trying to create a set. And then what set does is that they are unordered. Set does not follow a particular order, and then you cannot index a set. What I mean by index is that if I have, okay, I should let me explain that very quickly. If I have a list like this, let's say I have one, two, rather, let's go with fruits name. I have apple, I have orange there, and then I have um avocado. Okay, these are list of fruits, right? And then when I mean by um this is list of fruits is equal to this items here right now. So when I mean indexing is, I want to pick out apple from this list. Are we together? And then I will not call the name apple. I will use the index value of apple to represent apple. So in under indexing, what we make use of is the first value inside the list goes with the index number of 0. So if I should write list underscore fruits, and then I give it an index value of 0, what it will bring out is um sorry, is list fruits. I spelled the fruits wrongly, that's why I'm having an error. Sorry about that. Okay, it should bring out apple. Do we see it now? So that means a list can be indexed. Are we getting what I'm explaining? So I've been able to pick out apple from this entire list now by using the index value of 0. So if I use the index value of 2, if I put 2 here, what should come out should be avocado. That's going by that order of indexing. This should be 0, 1, sorry, 0, 1, and then this guy should be the second one, which is 2. The third one, which is index number 2. So that's how the order goes. So but then when we are creating a set, we are saying that a set are not order. So if this guy was a set, let's use a coily bracket so that we experiment what we've said, and then we'll be able to clear the doubts in our hearts. So this is a set now. Let's try to index this and see. Okay, see what it's telling us now. Set object is not subscriptable. So we cannot use the index value for these guys to pick up the values inside that set. But remember, when we make use of how do they call it? The list, we're able to index. So if we turn this thing to a curve bracket, this is a curve bracket. I remember a curve bracket will give us a tuple, right? And then if we index this, it will give us avocado. Are we following? So that's to tell us that sets and are actually not ordered. They don't follow a particular order, but then they are also not indexed, and then you cannot change anything inside uh, a set. And another thing is that once a set is created, you cannot change items in them, but you can always add new items, and duplicates are not allowed. So one of the best examples of a set is um the days of the week. So the days of the week are so unique that we cannot have 2 days having the same name. What I mean is that, let's say this is days of the week. Let's have days of the week pardon me, may not be able to type as fast as you may want. And then we are having a coily bracket. We have, let's say, Sunday and Monday, Monday. And then if I'm coming here to tell me that we also have another Monday, and then I try to run this, let's say, let's say this guy should print this thing for us. Let's see what will happen. Okay, you realize what is printing out, right? It's printing only Sunday and the first month. It is not including the second one here. So can we see that now? So it means that whenever you're creating a set, that set must be unique. The values in that set must be unique, in the sense that the first value here must not be the same thing as this value. Otherwise, it will pick one of the values inside of it and then print out. So when you have different values inside a set, and then you're trying to output those values or trying to pick those values, it will only bring out one of the unique values you have. So, but if we have Tuesday, Wednesday, Thursday, Friday, Saturday, it will output everything, and then we'll have it to be printed very, very correctly. So we've talked about duplicates are not allowed, but we can always add new items to read. So let's look at the codes I prepared here. So the first, okay, we've not talked about dictionary, please, Mike. I beg your pardon. Dictionary, they are created using coily brackets. So the same coily bracket, but there is a difference between dictionary and sets, which you have to pay very rough attention so that you can get it very clearly. They are used to store multiple items, and then in dictionaries, we store these items in key and value. So we have a key and then we have a value pair. Okay, look at how this is being done. I have a dictionary here, and this is how the dictionary looks like. So I have a first name, I have a Ben, and then I have a surname, I have a name, I have nationality, Nigerian. So this first guy here is the key, So it's just like you saying that you're having a variable. Remember when we said x is equal to 2, or rather 2. We said this x is a variable, and then this 2 is the value that is assigned to x. So whenever I call x, two should appear, right? So the same thing applies here. This is a key, which is first name, and then followed by a column. So this column is now trying to demarcate or trying to tell us that the next thing that is coming is the value that is to be assigned to this key. So the value that is assigned to first name is known as Ebenezer. And then the second key there is surname, and the value assigned to it is this. And then the same thing applies to nationality. The value assigned to it is what? Nigerian. And then if I want to print this my dictionary name, let's have this my dictionary, and I'm having this. So you see that it's showing very correctly that the first name is Ebenezer, the surname is this, and Nigerian nationality is what? Nigeria. So what dictionary helps us to do is it helps us to create a data frame. So if I want to create a data frame now, I can choose to have a list here. So I can have a list of people with their first name. So this is Ebenezer. I can have the next person to be let's use the people on the call, Matthew. uh, I can decide to have Caleb. If your name is not here, I beg your pardon. Maybe I'm not seeing your name currently. So if you look at this, these are the first name of these persons. This is the first name of Ebenezer. This is the first name of Matthew. This is the first name of Caleb. And then I can also decide to choose to put their nationality. I'm sorry, their surname. Pardon me. I'm going to give you some dummy names. Matthew, you're going with Monday, and then Caleb, you'll be going with uh, let's give you a name, Ade. And then let's look at the nationality. So the first person is a Nigerian. Sorry about that. The first person, sorry about that. The first person is a Nigerian. And then I'm saying that the second person is, let's use Italian for him. And then we are having another Nigerian. Okay, so you now look at this is looking more pleasant because I have multiple values being assigned to this key now. So if I should print out this, you'll be having it this way. That's the first name is Ebenezer. And mind you, when you're indexing, this first name goes alongside with the first surname. What I mean is that this first name goes alongside with the first surname, and it goes alongside with the first nationality value that is being given there. So Ebenezer Aniu is a Nigerian. That is what it implies. And then we have that Matthew Monday is an Italian, or it's okay, he's an Italian. And then we have Caleb Ade is what? A Nigerian. So that's how it is. So with this, we can create a table when we are making use of pandas. When we get to that guy will also let us know. So we have to run faster. We have other things to do. So they are ordered, changeable, but do not allow duplicate keys. Okay, this is my explanation now. These are your keys. So we cannot have two same variable names here as keys. This is what it implies. If I have here to be first name, and I'm having here to be first name as well. Sorry, that's my bad. I didn't copy this properly. So I have here to be first name, and I'm having here to be first name again. You realize this guy will not output the first guy. I seeing it now. So it's only giving us this other one, which is Anime Monday and Adi together. Are you following? So, but then because we want the keys to be distinct and unique, we give this guy a different name, which is surname. So when you give it surname, it outputs actually a variable like this. So that's for dictionary. And we I was trying to showcase some some data types here. That's just me playing around with this guy. And then I have x equals to my variable, which is equal to 3. Okay, somebody might want to ask, can we change one data type to another? Yes, we can do that. So we have an example here. We have my variable, which is the first one, which is equal to 3. So we want to see what this variable name is. And then the variable name, the type of this variable name is what? An integer. If I run this code, I will have what? Int, being an integer. And then I want to convert this 3 to a string. Remember what we said previously, that it has to be enclosed in a quotation mark. So when I enclose my x in quotation mark, it becomes what? A string. So but then before I can enclose it in a quotation mark, I can also decide that I want to use their keywords. So this is x, and I say string this x for me, which is 3. Are you getting me now? This string will convert this value inside of it to a string. What I mean is that let's copy this and explain this explicitly. We have x is equal to, previously, let's do this. Okay, we have previously that x is equal to 3 all together. And then when we have x is equal to 3, let's check the data type of this guy. It will tell us that x is an integer. Are we following? So because x is an integer, we want to now convert this x being an integer here. At this point, it was um an integer. So we want to convert it to a string. Converting it to a string will require us to use the keyword str. So these are the keywords we need to take note of. So these are the keywords str. We need to note that. We need to note int. We also need to note flot. We also need to note bool. So these are the 4 major this thing, data types which we have, so which we need to take note of, so that in case you want to convert from one data type to another, you'll be able to do that very, very well. So we have a string, we have integer. So we want to convert 3 to a string now. We'll have that our x, which is now a string, let's put a string, x string will now be equal to string, open a bracket and put 3 inside. So why we are opening this bracket is telling us that we want to impute a value inside of that bracket. So any value we impute inside this bracket will be operated on, and that's what will be coming out as the result will be our x string. So this 3 will become a string. So let's check the type of let's check the type of x string and see what we will have there. So let's run this code. We now have that it is what? A string. So that is how to convert from integer to a string. And then we can also convert this string back to integer. But mind you, in converting strings back to integers, those strings must be or rather, will I say those strings should rather be numbers that are string. So what I'm saying in essence is that if I have, remember our variable name here, which is x string. So I have x string, and then we know that is equal to 3. So if you look at this very well, you're seeing 3. This 3 is being enclosed in a bracket. But if I'm printing this first one, x, you'll see that this x is not enclosed in brackets, showing this a integer. And then but this one is being enclosed in a bracket. So if I want to convert this one back, I'll still make use of the keyword. This is now x in integer will now be equal to int of x string. So I'm now converting the value that is here to an integer. So let's see what type will come out. Data type of x integer. Sorry, that should be x integer rather, not. Okay, we now have it to be what? An integer. So that is what it is for conversion from strings to integer. So if I have a what if I have a string that is a name? Remember my name? There's a variable name called my name, which is actually my name. So let's see if we can convert this my name to a string. Let's try to convert that. My name string. Let's see, there should be an error here. So let's see, my name string equals to, let's convert int of my name, but I don't expect this to give us a good answer. Sorry, not dictionary, it should be a name. Okay, all right, so my name string should be, all right, we now have that. Look at this now. The value error is telling us that there's an invalid literal for integer, for integers. So integers has to be numbers that are in base 10. This is this is becoming interesting. So numbers that are in base 10, it means that the number should be between 0 to 9. So anything outside 0 to 9 is not even an integer again. So that's what this guy is telling us. So this literal, which is EBENZZE, is not a literal. So that's why it is actually, it cannot be converted back to integers. But anyone that is a number can easily be converted to integers. And then another thing is that we can convert from integers to floats. We can convert from integers to float using FLOAT. That is the name. This is it here, float. So we can convert. So let's convert x. Remember, our x is equal to 3. And then we want to convert this x to float. So let's have x float to be equal to, let's float x, and then we now check, let's check for the type. The type of x floats will now be so we are now having it to be a float now. So let's look at the unique output that will be printed out. That is x floats. We are having 3.0 now, other than the 3 whole number we had previously. So what's float will do is it will just add a decimal number. Sorry, it will just add a decimal point followed by 0, which is literally in mathematics is the same thing with 3. But then we can call this a decimal number because it has a decimal point. So that's what float does. So if I'm doing this, you see the conversion that is being done. We have string 3 being converted to a string, and then we have that same 3 converted back to integer, and then we have it converted back to float. So in float is 3.0, and then in string is this, and so on and so forth. So the next thing is explanation of sets, how set looks like. So in sets, if I have a list, okay, this is it first. Let's check for a list. Let's have a list of even numbers. So we have even numbers. A list is created by using a square bracket. This is a square bracket here. So that's being a square bracket. We have 2, 4, 6, please, and then 8, and okay, let's stop with this. 8. So we want to, this is a list because if I check the type of even, it should give me a list. Yeah, so it's a list because it's being created with a square bracket. And then we want to convert, this list to a set. In converting this list to a set, what we will do is we make use of the keyword. Remember, if you want to check the type of data type or data structure you're working with, you make use of the keyword type. So all these things that when I kind of impute them or type them in the notebook, it changes color to, I think this should be kind of green. Those guys are called keywords. So print, type, all these floats, int, string, they are called keywords. So when I want to convert from a list, so let's deal with sets. A list to a set, we now have even sets. So we have even sets, even equal to so what you do is you use the keyword set, and then you impute what you want to convert to a set, which is even, right? So when we do it this way, the next thing that should be imputed, that should be outputted, if there's anything like that, should be a set. So let's check even set. Let's check what will come out. Okay, we now see what we had in a square bracket is now in a coily bracket. So this coily bracket is telling you that this is a set. So we can choose to, okay, let's use the keyword print so that we can be learning with the keywords as well. So when we say print, it will print out that guy. And then we can also say print the data type, sorry, print the type of even sets. So when we are creating the type of even sets, so we now have two outputs here. We have the first one, which is a set, and then we know that the class of this data structure is called set. So that settles that for converting from list to set. And then we can also convert this set back to list using the keyword list. So when you want to convert back, it like can say set list, even list is equal to, so let's list even set, right? So when we list even set, we'll be having, sorry, this ought to be okay, even set. So sorry, we ought to print even list rather, not even set, please. Even list. Okay. Yeah, is now in a square bracket again. So you see, to convert from list, you use from list to set, you use set as a keyword. Then to convert from set back to this, you use list as a keyword. So that's what explains that for this. And then we will be looking at arithmetic operation. So under arithmetic operation, we have addition, which is plus. Please, can someone confirm if you can hear me? Can you all still hear me?
Yes.
Yes, you can.
Okay. Okay. Thank you very much, please. Okay. We have addition, we have subtraction, we have division. So now I was able to showcase the symbols we use. So for addition and subtraction, we use the normal mathematical symbols, and then for division, we make use of the forward slash. And then when we are looking at multiplication, we make use of asterisks other than the normal cross we used to use. And then we also, when we are talking about exponential, like when you're looking at raised to power, we make use of double, how do they call this guy now? Double asterisks. Okay, so let's be experimenting it very quickly so that we buy some time. So for the first one, if I say 45 plus 5 and I run this code, you see that this will give me 50. That's what um Python can do for you. So this guy can easily give you an answer which is very, very correct. So the same thing goes for, if I'm doing 5 times, remember you have to make use of your asterisk. 5 times 2 should give you what? 10. So when we have 5 times 2 giving us 10, it means that we've been able to perform multiplication with Python. And then we can 9. So you remember what I said about the forward slash. It's 1 dividing 9 will give us 9.0. So one thing with this division now, the forward slash, is that it will return an answer which is always in a float, like in a decimal point. So when I have this guy dividing this guy, instead of it to give you the normal 9 as per basic arithmetic, like in your mathematics, it will now give you 9.0 because it's now returning it in form of a float. And then for exponential, let's say we want to take, let's say we are looking at what can we look at very quickly now? um let's use, we are looking at 2 raised to power, let's say 2 raised to power 3. Let's see what the answer should be. So here, the value which you want to raise to the power is the one on the left, and then you input your asterisk twice and then 3. So let's see this, it will give us 8. So we are having this 2 raised to power 3 being 8. That's 2 times 2 times 2 times 2 is giving us 8. So this is it. So you can decide to put a space, you can decide to clear up the space. It just depends on the beauty you want to create. And the same thing goes for binary. If you make use of this number now, let's say we have 5 and 2, it will give us 7. So this is for binary now. We are working with 5 under 2. So it will be very, very hard for me to explain this if we are not really grounded in mathematics. But let's work with the basic ones we have for now. And then we have whole number return. Okay, this is what I wanted to explain previously. Whole number return has to do with, if I'm dividing, we know that if I'm dividing 5 by 2, it actually should be 2 remainder 1. So but let's see what will come out. What will come out will be 2. So if I'm using normal division signs, this is what it should give me. The single forward slash should give me a 2.5. So the 0.5 should be a remainder of 1. But then what this double slash will do is that it will neglect the decimal part of the solution and just give you the whole number part of the solution. So that is what this double slash stands for. And then for remainder, what remainder does is that remainder only gives you the remaining part of the or the decimal part of the solution, and then neglects the whole number part. So it depends on what you want and at what point you need them. So let's still go with the 5 dividing 2 again, and you see now is outputting 1 as a remainder. So if I'm saying that 5 whole number divide 2, it will give me a 2. And then I'm looking for 5 remainder. The remainder that I will get when I'm dividing 5 by 2, it will give me what? 1. So that is just how all these basic operation work. So, and then we have some keywords we need to acquaint ourselves with as well. The first one is sum. So if I have a range of values like this, I have 3, 5, 7, 8, and then I want to sum them all together. Other than me saying 3 plus this, I can easily put them in a tuple like this, and then I now use the keyword sum. So this sum, what it will do is that it will add the first value to the second value. The solution of the first, or the addition of the first and second value, will be added to the third one, and then consecutively until it gets to the last one. So if I'm doing this, I should be having 3 plus 5 should be around 8, and then 8 plus 8 is 16, 16 plus 7 is 23 already. So that's for that. And then I can also decide to give values or variables names. So I can say z is equal to 3.0. So let's z be a float. Remember, when it has a decimal point, is a float. And then y is equal to let's use 3. and then I run this, and then I can say whenever I call Z or Z, 3.0 should show. And then when I call Y, 3.3 whole number should show. And then I can operate on these two guys and say Z plus Y should give me what? A 6.0. So we can see that. So it will add the value that is assigned to Z and then to the value which is assigned to Y. By so doing, we will have a 6.0 as our output. We understand. And then there's another keyword known as minimum. Minimum. So this minimum, what minimum does is that minimum checks through the range of values or the set of values you've imputed, and then it will pick out the least value among them. So if I'm having a range of values 3, 5, 7, 8, and then I'm trying to get the minimum value will always be what? 3. And then there's another one known as, which is the opposite of this minimum, which is maximum. So if I try to make use of maximum, that's max, it will give me the maximum value, which is 8. So all these keywords will help save your time other than scanning through all these things. You know, when you're working with a big data, you will not just have this 4 data points. You can have like hundreds of thousands of data points. So it won't be easy for you to be scanning through all that. You make use of these keywords to be able to sort out what you're looking for very quickly. So this is I think this was supposed to be the explanation I did for whole number division. Should give us 3. Remember, 10 dividing 3 will be 3 remainder 1. So the remainder will now be 3, and then this for exponential. So that settles that for arithmetic progression. In case you have a question, you still reserve them. I will attend to them very, very shortly. Our time is running fast. Okay. We also have, we are supposed to cover Python conditionals. Python conditionals. If you've gone through those materials on the classroom I posted previously, you should be acquainted with all these things I'm saying today, because they are very simple. And then the first thing I'll be looking at is conditions. So conditions, when you're testing for conditions, we are making use of so you're trying to compare two things together. So the first condition is when you're trying to see if those two things are equal. So this is it now. If A is equal to B, do something. So if today is Sunday, go to church. So that is what it means. And then we have another one that is not equal. So I can always say that if A is not equal to B, do another thing. So all those conditions, this signs helps us to execute those conditions. And then there's another one that is known as less than. Less than, your normal less than in mathematics, the same thing applies here. So if A is less than B, we can say that A is this. If A is less than B, we can say B is that. So that's the same thing that applies here. And then we have less than or equal to. So what less than or equal to does is that when I say A is less than or equal to B, it means that the value of A can be B or lesser. So that is what less than does. So it will test for values that are actually the B value and the ones that are lesser than B. And then when I look at another one is greater than. So under greater than, we have um, A being greater than B. It means that A can never be B, but A can always be greater than B. And then we also have greater than or equal to. So it can start from B and then above B. So that's for that. And then let's try to test some conditions. In testing conditions, what's what the results you get are usually Boolean, because they are kind of logic kind of testing you're trying to perform. So I'm looking at, can 10 be greater than 3? And I'm asking Python, can 10 be greater than 3? Actually, we know 10 is greater than 3. That is why it's outputting what? True. And then we are also saying, is 200 being an integer equals to 200, which is a string? Remember, this 200 is now enclosed in a quotation mark. So this 200 cannot be equal to this 200. So that's why Python will tell you no, that this 200 being a string cannot be equal to this 200. So that's for that. But then when we now ask, can this 200 be equal to this 200? Python will tell you true. Reason is that this is 200.0. It's not 200 point, but if I have 200.1, it will tell us false, because 200.0 is the same thing as 200, but it only see this guy as a float when you were considering data types, but all of them are what? Numbers. And then it will say no. So that is for conditions. When you're looking at, is this variable greater than this one, is this one equal to this one, and all that, that is when you're talking about conditions. And then we have if statements. If statement, I was talking about if statement when I was introducing the course previously. The if statement is used to test, oh sorry, my bad. The if statement is used to test a condition and execute a block of code if the condition is true. So just like the illustration I gave to us, if we see the weather getting cloudy, we know that it will rain. Oh, that's not a very good example. So if we send a child to still go and get a biro, and then we get the child get there and there's no biro, we can say, oh yeah, if there is a book, you can purchase a book. So that's what if statement does. So this is how if statement is written in blocks. So you start with if is a keyword, you start with if, and then the condition. You now put the condition. So this condition you're given, remember how we say our conditions. This is the conditions here. So you need to take note of this conditions I've given to us here. So if you put the condition, then the code you want to execute. So whenever this guy is true, whenever this condition is true, the next block of code will be executed. So let's try that to see. We say that somebody's age is equal to um is equal to 18, and then we now ask, we now give a condition. If age is equal to or greater than 18, let's print that the person is an adult. So this will now, this variable age is having a value 18, but then the condition here is that if this age, remember, this is greater than and is equal to at the same time. So if it is greater than 18, print that the person is same time is equal to 18, print that the person is an adult. So let's run this code. It will tell us what you are an adult, right? So let's change this age. What if we have less than 18? Let's take like 17. Let's see. This code will not run. It will not output anything because we did not specify for when the condition is less than 18. So can you see this now? So it means that, okay, you're sending someone to get something, and then you're being strict with that person. If it is not ever soap, don't buy any other soap. Come back. So that is what this code has just done now. So if it is not greater than or equal to 18, don't print this guy in the next code block. So we are having this being equal to 20. It can give us that we are adults. Okay, so Python developers now realize that if we are working with if we are being too rigid with this our conditions, we will be losing so many things. So that's why they came up with another thing that can help complement this, which is if else statement. So what if else statement does is that when you are testing for the first, when you're testing for the first how do they call it, the first condition, and then it doesn't work, there is a second option for you. So that second option is where your else statement comes in. So you are testing if, and then there's a condition, and the condition is saying that if that condition is true, you should execute that code. But if the condition is not true, execute the one that is in the next code block. Okay, let's go. Let's have an example now. The example here says that the person's age is equal to 16. And then remember what we said previously, that if age is greater than or equal to 18, we should print what? That the person is an adult. And then remember what we did previously, that when we had that the person's age was 17, Python did not output anything for us. But then because we have now brought the else statement, it will help complement to print the next thing. So we are having that if age is greater than or equal to 18, print this, and then let's run this and see. So you realize that since the age is 16, the person is now what? A child. And then if I change this my age to 25, you will see that it's now printing what? The person is an adult. So that's what the else statement does. So else statement helps to account for when the first condition, which is this one, is not met, then the next one will be executed. And then there is still uh, a problem. What if we have um, what if we have a condition that is in between the if statement and the else statement? Let's say, for instance, we want to pick people between the ages of 18 to 20, and then we are looking at the ages of people between 18 to 20. We cannot say that this code will work well for us, because here we were just saying that if you're 18 and above, so the person can be 100, can be 200, and then the code will still run. But if we are looking at the range of people from between 18 to 20, we will not be able to spot that out. So that's why we also have something that is called the if and else statement. So this if is going to test for the first condition, and then if the first condition is met, we now print this line of code. And then the else ifs is what comes in between, is an intermediate between the ifs and the else statement. So this else ifs, if the condition that is specified on this else if is met, it will now what? Execute the second line of code. Otherwise, don't do anything. Just come to this last guy and output what is here. Okay. We have a grading system here that helps to allocate grades to people. Again, so we are saying that we want to we are trying to build a grading system, and then whenever somebody have 90 and above, the person is scoring an A. And then when somebody has uh 80, when somebody has 80, above 80 should be a B. And then when somebody has above 70 should be a C, and below 70 should be an F. Sorry, this is just a demo class, sha, but that's not really in the real world. Is not done that way. So if somebody scores 100, let's check 100, or have that the person is scoring is having what? An A. I get it. And then let's see if when somebody scores 89, what would that person have? I think the person should have a grade of B. So that's to tell you that if you're scoring anything less than 90, you will fall under grade B, right? And then if you're scoring anything less than 79, your grade will now be C. And if you don't have up to 70, that, that means the person has failed the, the course. So that's how it is for if elif statement. So you can have multiples elif statements. So I can decide to have another elif statement here. So let's see what we can have. Okay, I can decide to have another elif statement here to account for 50. If you have 50, you can have a D. So let's see if somebody can have a D. Let's check for someone that's scoring 51. 51 will be a D. So that's what an if statement does for you. And then The next thing on our conditions, iterations, and loop is the loops rather. So under loops, we have the for loops and the while loops. So for loops, what loops does is that, like I explained when we began the classes, I was saying that loops are conditions that, or rather, loops are used to test a block of code or a condition that when that condition is true, it will continually run. So long as the first day of the week is Sunday, people will continually go to church. So that's just what it means. And but if that condition is not met, that code will not run. So we have the first one, which is for loop. So you make use of for, which is the keyword for that particular loop, and then we are saying that for item in a sequence. So we are saying what, for item in a sequence, let this code block be executed. Okay. And I have a list of fruits here. I have apple, a banana, and cherry. And I'm saying that for a single fruit in this list of fruits, I want you to print out the fruit. So what this code means is that it's you come to pick each of the fruits that is in this list one after another until it gets to the last one. Are we together? So long as that fruit is inside fruits, it will pick it out. And then this is how it is. So we are having that for fruit in fruits, print fruits. And then take note of the way I wrote this thing. So I'm saying that the list itself has so many fruits inside of it. That's why it's a plural. That's just me being careful there. And then for fruits in fruits, are we together? For fruits in fruits, we now print the single fruit. So we have to print one first. So when it finishes the first one, when it picks the first one, it will go back to test if there's another fruit in this fruit. It will now pick it and output it, and then it will also test. So at the end, when it got to this cherry, there was no fruit again for it to print. It stopped there. So if I say I have 12, it will still print the 12 because it's considering this 12 as an item inside of fruits. Are you getting me? So long as that item is inside this list, it will print it out. So that's what for loop does. And then another illustration is in this one now. This one is when you're trying to get a list of numbers. So this is how it works. This is the smallest number, and then this is the highest number in this particular tuple. But then I want this number to be I'm coming. Let's test for something very quickly. All right. I want these numbers to be counting from 1 to 10, but it should have an interval of 2. This to say, if I have 1, the next number that should appear should be a 3. So I don't even understand what I'm saying. So this is how it is. Let's represent this in a list so that we can confirm it. So we can say odd numbers is equal to, let's create a list. Okay, x for x in the range of this guy, and then we now print odd numbers. Okay, let's print the odd numbers and see what will come out. So this is what I was trying to explain, that this particular range 1 to 10 and in step of 2 is telling us that if the first value is 1, the next one should be what, 3, the next one should be what, 5. So it's having an interval of 2, so you have to skip a number before you output the next one. So that's what it is. And then when you're printing, it will now bring out what, 1, 3, 5, 7, and 9. I hope we are still following. Yes, the notebook will be shared after today's class. Sorry, I didn't see that. Yes, I will share this notebook after the class. Hope we can still hear me, please.
Yes, we can hear you, sir.
Okay, so let me try to round up so that I can take questions if you have any. All right. Then the last one I was saying that I will look at is functions. Just like we said, a function is a reusable block of code that performs a specific task. So this specific task is very, very important, and the phrase reusable block of code, rather, those two guys are very important. So functions help us to organize code and then makes it more readable and then avoid repetition. So this is a typical function we are having here. The first thing the first thing is you define your function name. This is where your function name will be. And then these are the parameters inside your function. And then once you have those parameters inside your function, once you have those parameters inside your function, the next thing is followed by a column. So what column does is that column will let us know that, oh, we are writing a block of code. That means after this particular first line, everything on this second one will be indented. So this is what indentation means. You're giving a space like this, as if you're, or how do they call it in English? I think paragraph, as if you're doing a paragraph kind of work. Okay, so it will be indented automatically. So we are having that. Let's do this very quickly. We define, we use the word def. So we are defining a function. Def means defined function, right? And then the next thing that would follow that function after a space is going to be the function name. So this function name here is what you will use later to perform any other operation you want to perform. And then we are giving it two parameters. We have A and we have B. And then remember I said he has to be followed with how do they call it, a column. So because it's followed with a column, if I press enter, it will indent it automatically. That's why the use of Jupyter Notebook is very, very good, because some of these things you don't need to indent it yourself. It will indent automatically, other than when you're using a VS Code. And then I now say return return A plus B. So what return can only be used like a print function when you're dealing with this self-defined function. Okay, let me say that again. Remember we made use of print. If I say print 2 plus 2, it will give me 4, right? But I cannot say return. Let's see what return, and then I will explain the difference for you. All right. See now, I'm saying return 2 plus 2. It's telling us that we're having a syntax error now. The syntax error is telling us that return cannot be used outside of a function. Are you getting this? So it's only when you have defined a function by yourself and then you want to use that function, you're not saying that you want to return this particular operation inside this your function. So now we've defined this function. Remember, we use the keyword def and then the function name add, and then the parameters that are inside A and B, followed by our column, and then the indentation is being initiated, and then we have return this guy. And then how to make use of this code now? I will now use, remember the function name add. If I say add 3, 3, this will output 6 for me. Are you getting me? So it's just like when we made use of the function sum. Remember we did something like this: sum 2, 2, and 3. So it was giving us 7. So this sum is actually a function that Python developers have written that is now becoming a keyword for us that we use. Are you getting me? So And this one, we are now defining it for ourselves that whenever we call add, and then we input two values inside, or two parameters rather, not values, two parameters inside of that particular function, it should do what? It should add the two functions together for us and return the answer. So that is what it is. And then you can also use it in this way. You can say, making your code to look beautiful, you can say result is equal to, you add 3 and 4. So adding 3 and 4, you print your result, will now give us what? 7. So that's what function does for us. And then we also have augment function. So what augment function does is that sometimes you may not be able to input all the parameters here. I get me. Augment functions allows us to use um, Python functions inside of it. This is what I mean now. I define this guy, and then I have a name for it, which is add, right? Okay, let's use add aug so that it will look different. Add augment, and then I'm saying that it should return arguments, and then it should return what? The sum of arguments. So it should return the sum of anything that is put in this place. So argument means like you can input any number of values inside of here. I get me. So long as you input those number of values here, it will always sum them together. Are we following? So if I run this, and then I come here and say add arguments. Add arguments will add this first one, 30 plus 30 is 60, 39, and so on and so forth until it gets to the last one, which will give us what? 87. So that's for augment function. So you don't need to specify how many parameters can be here. So we can decide that we want to use just two parameters and it will still work. Let's see this. It's giving us 6, right? So we can also want to what? Okay. We can also want to choose lesser, like 3. It will still work. I think this 11 because 2 this guy should give us 6 plus 5 should be 11. So that is what augment does for us. The last one I'll be looking at, I hope is the last. Yeah, the last should be lambda function. So lambda function is just like a simple lambda is a keyword actually that allows us to perform some operations. So I have a variable name called lam, and then I'm saying that we want to lambda x. We want to perform operation on x. So that's why I what's the word? I initiate x here as a variable name, and then I now say after initiating the x, you now put a column. This column is telling you that you want to perform an operation now. So after the x, you want to perform an operation, and the operation must be with respect to what you've initialized here. So we are saying that we want x times what is here. Are we together? So because we want to do x times what is there, we will now say lambda x column x times 6. All right, and then I now call my variable name, which is lambda, because whatsoever I do here is being stored on this name. So when I call this name, is what is happening here that will be played. I don't even understand, or that will be showcased rather. And then if I call lambda and I give a value for my x, which is 20, it means that it will return what? 120. This 120 is returning is because it has what? Done it has done what? 20 times 6, giving us what? 120. So if you check the normal 20 times 6, let's see, 20 times 6, yeah, it should give us 120 as well. So that's for that. And then we can also use it to perform some squares, you get. So when we say um lambda x, and then we have x, remember when we have two asterisks, it means that these two asterisks are for exponential. So we'll be having this x raised to power 6. So when we do square of 7 raised to power 6, it should give us this 1176.49. That's 117,649. So that ends the class for today. I will really want to entertain questions. But while I'll be waiting for questions, we have an assignment here. We have an assignment here. Let it come up. Uh it's a very, very simple one. So you have an assignment here to perform. I will be sending this to the classroom. It's very, very simple. So please endeavor to do it when the assignment arrives the classroom. All right. I would like to know if there's any question, if there are questions, things you don't understand, or was I too fast? Just let me know so that we can reconcile all that while I stop sharing my screen very, very shortly. All right. Are there questions? All right. Matthew, ask your question.
Yeah, do ask some